Alright, so here this video is going to go over our review sheet that we started today in class. Hopefully you were able to finish most of it in class. The first 8 questions ask us to find the inverse of random functions. We see that this particular function in number 1 is a linear function, therefore its inverse is going to also be a function, which is why we can do this. You'll notice that is the same for all 8 of the questions in the first problem. So if we go through to find an inverse, the first thing we have to do is switch the x and the y value. And now we just have to resolve for y. So I'd start by subtracting by 7. So now I have x minus 7 equals 3y, and then divide everything by 3. Now, since this is a function, once I get y by itself, I can show the inverse in function notation. So that'd be f negative 1 of x equals 1/3 x minus 7/3. Hopefully that was a nice easy one to start with. The second one is similar. It's also a linear function, but you'll notice that there's some fractions here, so there's a little bit more that we have to deal with, but the same idea. So first step again is switch x and y. Now, some people in my classes today asked about this 5/8 and asked about the reciprocal. It's added, so I'm sorry, it's subtracted, so I'm just going to add it over to the other side, just like if it was a regular whole number. That's going to give me x plus 5/8 equals 1/4 y. Now, the reciprocal that we were talking about is only used when we have multiplication. So here the reciprocal of 1/4 is 4. So I'm going to multiply both sides by 4. That's going to eliminate this 1/4 and leave us with just y. So we can say g negative 1 of x, because we have y by itself, equals 4x plus whatever 4 times 5/8 is, which we'll see winds up being 5/2. And we're done. The next function gave us a cubic. So cubic functions we know can be have inverses that are functions because they're going to look something like this, right? So we know that that's going to pass the horizontal line test. If we want to check that, we can by plugging it into our calculator. But again, same rule. So I'm just going to switch x and y and try and get the term with y cubed by itself. So I want to move that 10 and I want to move the 2. So I'm going to add 10 to both sides. That gives me x plus 10 equals 2y to the 3rd power. And then I'm going to divide everything by 2. So that's going to give me 1/2 x plus 5 equals y cubed. Now I don't want y cubed, I want y. Now this is where we could kind of do 2 different things. So I'm going to outline 2 different methods that you could have done. The first thing you can do is you can just cube root both sides. So if I cube root both sides, I'm going to wind up having 1/2 x plus 5 equals y. Which I can then say, well, since y is by itself, I can say h negative 1 of x equals the cube root of 1/2 x plus 5. Totally acceptable answer, and I would love for most of you to do it that way. The other way you can do this is you can say, well, instead of saying the 3rd power, I can raise that to the 1/3 power. So what that would look like would be 1/2 x plus 5 to the 1/3 power equals y to the 3rd all to the 1/3 power. The reason why this also works is, well, 1/3 power is the same as cube root, and also the 3's would cancel there. So you'd be left with h negative 1 of x equals 1/2 x plus 5, all in a big parenthesis, all to the 1/3 power. These 2 answers are actually equivalent to each other, right? So don't let that confuse you. One of the things that they can actually do on the Regents exam is give you one or the other, so you should really know that they both work. For number 4, again, start by switching x and y, and then cube both sides. So now I'd have cube equals just 5 minus y. Because anytime you cube a cube root, they cancel their opposite operations. So now I could just subtract 5 by both sides. So now I have x cubed minus 5 equals negative y. But I don't want negative y, so I'm going to divide everything by negative 1. Which is going to give me m negative 1 of x equals negative x cubed plus 5. Number 5 is a little tricky because of the exponent that's given there. So if we first switch by making the x and y in the opposite spot, same thing, we want to try and get the term with y by itself. So I want to move that 2 and I want to divide by 4. So I'm going to add 2 to both sides. So x plus 2 equals 4y to the 4/3 power. Then I'm going to divide both sides by 4. So that's going to give me x plus 2 over 4 equals y to the 4/3 power. And then here we have an option. You can either change that 4/3 exponent to a radical and then use your rules of radicals to get rid of it, which would be a perfectly valid way of doing it. Or what I would do is just raise both sides to the 3/4 power. Because if you raise both sides to the 3/4 power, these are going to eliminate each other, making y by itself. And then we can say our final answer is going to be n negative 1 of x equals x plus 2 over 4, all to the 3/4 power. Now, if you had done it with radicals, you're going to get the same answer. It's just going to look a little different. So since this is exponent over root, this would be the 4th root of x plus 2 over 4 to the 3rd power. Those are equivalent answers, so whichever one you got is fine. Number 6, again, first step, switch x and y. Now again, we want to get the term with the y by itself, so we want to get y plus 1 to the 5th power alone. So I'm going to subtract 6, giving me x minus 6 equals negative 4, y plus 1 to the 5th, and then divide by negative 4. That gives us this y plus 1 to the 5th by itself. Now to get rid of that 5th power, we could do one of two things. We could take the 5th root of both sides, or we could use the 1/5 power to both sides. It really doesn't matter how you do it. So since we did exponents last time, let's do radicals this time. So I'll do the 5th root here. By doing that, I'm going to wind up having the 5th root of x minus 6 over negative 4. I'm going to put a parenthesis there just to show that all that's underneath the radical equals y plus 1. Still not done because I want to move the y to the other side, so it's the 1 to the other side. So I'd subtract by 1, and now I have k negative 1 of x equals the 5th root of x minus 6 over negative 4 minus 1. Now that's one possible answer. The other answer would be if you had used the fractional exponents, you would get this x minus 6 over negative 4 to the 1/5 power minus 1. They mean the same exact thing. Number 7. So for number 7, notice there are two x values in the original function. Therefore, when we take the inverse, you're going to have two y values in the inverse. So in class, we said as soon as we see that, we want to cross multiply. So if I cross multiply, I'm going to get y plus 6 equals 2xy minus 5x. Remember, this x gets multiplied to everything down there. Now our job is to get the y's together and everything that doesn't have y together. So I'm going to move this 2xy to the other side. And I know in class I did this all in one big step, so here I'm going to just show it all as separate steps. And then I want to move the 6 to the other side so that I have y minus 2xy equals negative 5x minus 6. So notice all the terms that have y are on one side, everything that doesn't have y is on the other. The reason why we want to do that is now on that left side, if you notice, y and negative 2xy have a common factor of y. So I can divide out y, use some math magic to make 2 y's into 1 y, and now I have 1 minus 2x equals negative 5x minus 6. I can then divide both sides by 1 minus 2x, and I have y by itself. So then I have j negative 1 of x equals negative 5x minus 6 over 1 minus 2x. Now there are other possible answers there, so if you got something different, don't just erase it all. Just see me in class tomorrow and I'll look at it. Just because of all the negatives, you can put the negatives in different places and make everything kind of look different. Okay, so don't freak out if you got something slightly different. Right, same thing here for number 8. So I'd say x equals 5y minus 1 over 2 minus y. Again, cross multiply. So I'd have 5y minus 1 equals 2x minus xy. And again, we want to get the terms that have y together and the terms that have no y on the same side. So I'd add xy, and I'd add 1. That's going to cancel here and here. Now notice everything that has y is on one side, so I'd have 5y plus xy equals 2x plus 1. This one's a little bit easier than the previous one because there's no negative numbers. Now just like we did in the previous example, we want to try and get a factor of y out of that left-hand side. So if I factor out y, I'm left with 5 plus x equals 2x plus 1. Divide both sides by 5 plus x. I have y by itself, so now I have p negative 1 of x equals 2x plus 1 over 5 plus x. All right. The next two questions gave us the inverse and wanted us to find the original function. Now in class we talked about how the inverse of an inverse is the original function. So this is just another fancy way of saying find the inverse of this function. So first thing I would do, just like always, I would switch the x and the y value. So even though the question is asked differently, it's asking us to do the same math. So I have to move the 3. So x minus 3 equals y to the third over 4. I want to get rid of the 4, so I'm going to multiply both sides by 4. So I have 4x minus 12 equals y to the third power. And then again, we have options here. We could either take the cube root of both sides or put both sides exponents to the 1/3. I'm going to choose to do cube root here. And since y would be by itself, instead of using inverse of a function, I'm going to say this is the function. If you want to get really crazy and check this, you could find the inverse of that, and it should give you the original function. 10 is the same thing. So if we switch x and y, I then would subtract 8 from both sides. So x minus 8 equals 1/2 y. Multiply both sides by 2. So I have 2x minus 16 equals g of x, because that y would then be by itself. Pretty straightforward. The next few questions asked us determine if each function or each relation is a function, and then also determine if it is a function if it was 1-to-1. So the first thing we're looking for, is it a function? So to determine if something is a function, we're going to look at the x values if it's a table. So look at all these x values, are all different. So it's a function because unique x values. Right, unique just meaning they're all different. Then to find out if it is a one-to-one function, we're going to look at the y values. So if you look at the y values, see how they're all different? So we can say f of x is 1 to 1 because of unique y values. So by looking at the table, we're able to determine that. Now, that question is not always going to be asked with a table. Sometimes it'll be asked with a graph. So here's a graph of a random function. This function we know is a function, or this relation we know is a function because it passes the vertical line test. Passing the vertical line test tells us that we have unique x values. None of the x values are repeated. This graph, however, fails the horizontal line test. See how if I draw a horizontal line, that red line there, it crosses the graph 3 times. To pass the horizontal line test, it has to cross just once. So because this function fails the horizontal line test, we know it's not one-to-one because there would be repeated y values. So we can say this is a function because unique x values, right, passes the vertical line test. It's not one-to-one because it fails the horizontal line test. Now, number 13 didn't give you the table of values and it didn't give you the function itself. The graph of the function itself. It just gave you the equation. So the first thing I would do would put that in my calculator and just see what it looks like. So if I graph that in my calculator, I'm going to get something that looks like this. So this function passes the vertical line test and also passes the horizontal line test. Therefore, this function is a one-to-one function. So I can say one-to-one function because unique x and y values. Right? The x and y values will never repeat. You'll never see the same x value in the table or the same y value in the table. Number 14 is the only example in this section that is something that's not a function. This fails the vertical line test, meaning that there are going to be multiple x values there. So we can say this is not a function because it fails the vertical line test. Failing vertical line test means that there are multiple x values in your table. Right, 15 through 18 is really just testing, do you know what logs are? And remember, logs we said are the what function, what power function. So what this number 15 is really asking is what power on 3 makes 81? So I know 3 to the 4th power makes 81. So this answer is just going to be 4. Number 16 is the same type of question. So it's saying what power on 5 makes 1 over 625? So I know it's going to have to be negative. So if I use my calculator and play around a little bit, so if I do 5 to the negative 4, that works. So if I do 5 to the negative 4, that would give me 1 over 625. So this answer is negative 4. Number 17 uses another kind of trick that we have with logarithms. So since we're saying what power on 4 makes 2, I know that that would have to be a 1/2 exponent because we would have radicals there. So we'd wind up having an answer here of 1/2. And number 18, what power on pi makes back pi? So what power on anything makes back itself would be 1. Whether it's pi or a different number, it doesn't really matter. Okay. The next set of questions give you exponential functions and ask you to find the inverse. So we know that if we see the x in the exponent, the inverse is going to be something that's a logarithm. So if we first start by switching the x and y values, I then can solve for the piece that has the y in it, so I would subtract by 2. So I have x minus 2 equals 8 to the y. So now we have to figure out, well, how is this going to translate into a logarithm? So logarithms are always going to be the exponent equals the log of whatever the base was, which was 8. And then whatever is inside the logarithm, whatever we're evaluating, is what the exponent was equal to. So in this case, it would be x minus 2. Then also, since this is a function, I'd want to put this in function notation. So I have log base 8 of x minus 2. Number 20 is the same idea, just has more steps because there's more algebra involved. So first thing we do is switch x and y. Remember, follow your rules of PEMDAS. You can't multiply that 2 and 4 together. I know you want to so bad, but you really can't. So I'm going to add 6 to both sides just to get rid of it. X plus 6 equals 2, 4 to the y plus 3. And then I want to divide away the 2. This way, that 4 to the y plus 3 is by itself. So now I have x plus 6 over 2 equals 4 to the y plus 3. Once the exponential piece is by itself, I can now rewrite this as a logarithm. Remember, logarithms are always equal to the exponent, so the exponent in this case is y plus 3. It's a base of 4, and then we're evaluating whatever the exponent was equal to, x plus 6 over 2. Now we're not done because I want to get y by itself, so I would have to subtract 3 on both sides. By doing that, y is now by itself, so I can say g negative 1 of x is equal to log base 4 of x plus 6 over 2 minus 3. Notice the minus 3 is outside of the parenthesis. Almost done. 2 more. So for numbers 21 and 22, they ask you to take the logarithmic equation and rewrite it as an exponent, or find its inverse. So if I take x equals log base 2 of y plus 1, now I have the inverses equation, and these are a little bit easier actually because they can be changed right away. So if this is the logarithm, the exponent that would match this would be 2 to the x power equals y plus 1. Because I know the base was 2, logarithms are always equal to exponents, so the exponent's x, and then the y plus 1 is what the exponent is equal to. Now I want to get y by itself, so I would subtract 1. Now that y is by itself, I can say h negative 1 of x equals 2 to the x minus 1. Last problem, hopefully you're still with me on this video. I know it's kind of long, but remember you could always fast forward them if you want to. So now if we have x equals log base 3 of y minus 4 plus 5, before I can change this to a exponent, I now have to move the 5. So I have x minus 5 equals log base 3 of y minus 4. So now if I rewrite this as an exponent, I know the base is going to be 3. It's going to be to the x minus 5, and the answer is going to be y minus 4. I then can add 4 to both sides to get the y by itself. So now I have g negative 1 of x equals 3 to the x minus 5 plus 4. And that's it. Hopefully this video was helpful.